according to the National Electrical Code, specifically Section 501.4 bone, magnetic door contacts, because they are not intrinsically safe, are not permitted to be installed in Class 1, Division 1 or Division 2 locations unless they adhere to the guidelines outlined in 501.4 bone. This section of the code details the requirements for preventing ignition-capable arcs or sparks in hazardous locations. Equipment that isn't intrinsically safe must employ one of two primary methods to ensure safety. Firstly, segregation of arcing or sparking components of the enclosure that contains them from flammable gases or vapors, as described in 501.4 bone and 501.4 bone. B. Secondly, extinguishing or cooling arcs and sparks before they reach an ignition-capable temperature, as outlined in 501.4 bone. C in 501.4 bone. D. Looking closer at segregation, 501.4 bone typically discusses explosion-proof enclosures. This approach involves placing the magnetic door contact within an enclosure specifically designed and tested to withstand an internal explosion of a specified flammable gas or vapor. The enclosure must also prevent the propagation of the explosion to the surrounding atmosphere. These enclosures are built to contain any explosion and, more importantly, cool the exiting gases below the ignition temperature of the hazardous atmosphere. The design requires careful consideration of flame path length, width, and other factors to ensure its effectiveness. Enclosures are marked with the class and division for which they are approved, as well as the specific gas or vapor groups they are designed to contain. Proper installation is crucial to maintaining the integrity of the explosion-proof protection, which involves ensuring that all enclosure covers and fittings are properly tightened and that any conduit entering the enclosure is sealed to prevent the passage of gases or vapors. Now, 501.4 bone focuses on purging and pressurization. This method involves maintaining a positive pressure of a clean, inert gas, such as nitrogen or clean air, within the enclosure containing the magnetic door contacts. The positive pressure prevents the ingress of flammable gases or vapors into the enclosure. Purging involves initially flushing the enclosure with the inert gas to remove any existing hazardous atmosphere before pressurization begins. There are different types of purging and pressurization systems, each with its own requirements for airflow, pressure, and monitoring. These systems typically include sensors and controls to ensure that the positive pressure is maintained and that the system shuts down automatically in the event of a pressure loss. Like explosion-proof enclosures, purged and pressurized systems must be carefully designed, installed, and maintained to ensure their effectiveness. Moving on to arc extinguishing and cooling, 501.4 bone discusses oil-filled equipment. While less common for magnetic door contacts, this method involves immersing the electrical components of the contact in oil. The oil serves to insulate the components, cool any arcs or sparks that may occur, and prevent ignition of the surrounding atmosphere. The oil must be of a type specifically approved for use in hazardous locations and must be maintained at the proper level and condition. The equipment must also be designed to prevent the oil from leaking or spilling in the event of a failure. Finally, 501.4 bone covers non-incentive equipment. Non-incentive equipment is designed so that it is incapable of causing ignition under normal operating conditions. This can be achieved through various design features, such as limiting the energy available in the circuit or using components that are less likely to produce arcs or sparks. Non-incentive equipment is typically tested and certified to meet specific standards for use in hazardous locations. It is important to note that non-incentive equipment is not the same as intrinsically safe equipment, which is designed to be incapable of causing ignition even under fault conditions. When selecting a method for protecting a magnetic door contact in a Class 1, Division 1 location, you need to consider several factors, including the specific hazardous atmosphere present, the size and configuration of the equipment, and the maintenance requirements. Explosion-proof enclosures are a common choice for many applications, but they can be bulky and expensive. Purged and pressurized systems can be a good option for larger enclosures or for applications where frequent access to the equipment is required. Oil-filled equipment is typically used for specialized applications where its unique properties are required. Non-incentive equipment can be a cost-effective solution for some applications, but it may not be suitable for all hazardous atmospheres. Regardless of the method chosen, it is important to ensure that the equipment is properly installed, maintained, and inspected to ensure its continued effectiveness. The National Electrical Code provides detailed requirements for the installation and maintenance of electrical equipment in hazardous locations, and it is essential to consult the code and follow all applicable requirements. In summary, installing magnetic door contacts in Class 1, Division 1 locations requires careful consideration of the potential hazards and the selection of appropriate protection methods. Understanding the requirements of NEC 500 burn is crucial for ensuring the safety of personnel and equipment in these hazardous environments. Remember that proper installation and maintenance are essential for the continued effectiveness of any protection method.